Okay, this is part 2 of Unit 6B. We're looking at, in this problem, we're going to find the mean, median, the range, 5-number summary, standard deviations, drawing a box plot. So we got a lot of things going on, and a couple other things there at the end. Here's our data sets. We have cost of living index for 6 cities with relatively high cost of living and 6 cities with relatively low cost of living. And here's what they're based upon. So we're going to find the mean, median, mode of the high cost cities. Oops. Sorry about that. iPad just turned off. And then the low cost cities. So I'm going to put this data into StatCrunch. I just want to remind you how to do that. So when we come over here, I've just come into a random problem. You can either click here on these little windows if it has it in a problem and open in StatCrunch, or you can click question help and then click StatCrunch. Either way, it's going to get StatCrunch to open for you. But if you use the little windows, then it will actually import the data for you as well. So what I'm going to do is this one I'm going to call the high cost, and those numbers were 228. Well, I'm going to do high cost, low cost, and then I'm just going to type these in. So I'm going to pause the video and get them all typed in. Okay, so now I've got both sets of data in here. So I'm going to click on Stat and Summary Stats by column. First I'm going to do high cost, and it's already got all of the statistics selected that I wanted. So I'm going to click there, and you can see there's my high cost. Then I'm also going to bring in my low cost. So now I can see both of them at the same time. And so you can see I've got my mean, my median on both of them. I've got the range, the minimum, the maximum, the first quartile, the third quartiles, or the lower and upper quartiles. So then we can transfer all that data over. So on this one, oops, get the highlighter on. So on part A, so we're going to do the high cost here. The mean is, let's see, where did that go? So the mean was 166. The median was 149. And the range was 83. Okay, and then when we look at the low costs, we have the mean here was about 80.67. The median was 81. The range was 7. So that gives us our mean, median, and range for the two data sets. Part B wants the data summaries. So for the high, I'm just going to put these in order. So the minimum was 145, quartile 1 was 148, then the median was 149, quartile 3 was 177, and 228 was our maximum. Then for the low, the minimum was 76, quartile 1 was 80, the median was 81, quartile 3 was 83, and the maximum was also 83. So what we need to do is we need to draw now a box plot for both of those. So my box plot here, I'm going to draw them both on the same box plot. So this could be low, this could be high. This will help us so we can see what both sets of data look like as far as spread and where they are on the same graph. So I'm going to do 50, 100, 150, and 200. Now on the low, This one's going to be a little bit hard to do because it's so tight. So our box goes from 83 to 80, and so that's going to be pretty tough to give us a good representation, but we're going to call that 83 to 80. And then I'll make it a little bit bigger so you can see it. So there's our box. Our median is 81, so that'll be our median right there. And then we go down to 76, and then our maximum is the same as that quartile 3, so it actually doesn't have that right-hand whisker. But there would be the box plot for the lower cost cities. Now the higher cost cities, we're at 145. Well, first let's create this box. So that goes from 148 all the way to 177. So I'm going to go 148. We'll call that 177. These don't have to be they don't have to be exact. They can be approximate. And then 149 is the median, so I'm going to draw the median there. And then we drop down to 145, which isn't too far below, but then 228. Well, I guess it's probably not to scale there. 220 is probably about right here. So we can see the spread in our box plot. We can see that the higher cost cities are much more spread out. There's much more variation in those. You can see that in the box plots. So that's creating the box plot. Next, we want to find the standard deviation for each set. Okay, if we go back, we can see the standard deviation here for both. So we have 32.6 approximately and 2.7 for the low. So we'll do, so S is short for the standard deviation. So I'm going to say the standard deviation of the high was approximately 32.6. The standard deviation for the low was approximately 2.7 units. And we can see that, again, standard deviation talks about spread, and we can see that the high has a much bigger spread than the low. And so that is noted in the standard deviation numerically and graphically in our box plot. Okay, and the next we want to go to part D, and in part D it asks us to apply the range rule of thumb to estimate the standard deviation and how well it works. Okay, remember the range rule. So here's for the high. You take the range of the high was 83, divided by 4, and that's approximately 20.8. And then for the low, we're going to take the range, which was 7 divided by 4, and we get 1.8. Again, we're rounding to the nearest tenth on those. And I mean, they do show us that there's good spread as far as the low has a low standard deviation, the high has a much higher standard deviation. But in both cases, we're off by a bit. The lower is I mean, closer. We're off by 0.9, but the higher is quite a ways off, and notice that is because of the Manhattan outlier that really tugs and pulls that pulls away the mean, and it throws the range out really wide, and that's going to affect your standard deviation greatly. So they're not the best measures, but again, they're quick measures. And so again, we've talked a lot about, as far as part E, you know, some of the differences and things that we see here. But I mean, the biggest thing is that the high cost cities have much more variance. We can see that in the box plot. We can see it in the standard deviations. We can see it in the range, and all of those work together. So let me just check my time here. Okay, so let's look at this next one. We're looking at pizza deliveries. So after recording the pizza delivery times for 2 different pizza shops, you conclude that one pizza shop has a mean delivery time of 30 minutes. So the abbreviation for mean is what we call X bar. So I'm going to say X bar sub 1. So this was the mean for the first business is 30 with a standard deviation of 3 minutes. The other shop, so this I'll call this X bar 2, has a mean delivery time of 29 minutes, standard deviation of 12 minutes. And we want to interpret these figures, and if you like both pizza shops equally, which one would you order from and why? So when we look at both of these, the means are almost the same. I mean, they're really close with 29 and 30. But if we look at the standard deviations, the standard deviation for the first is 3. So that means that shop 1, so if we look at pizza shop 1, shop 1 is more reliable because it has a smaller standard deviation. So they're going to be contained. You're going to see a lot more deliveries between 27 and 33 minutes. If you go one standard deviation above and below, that's where a lot of bulk of your data is going to lie. And if you go 2 standard deviations above, 36 is a high, and down to 24, that's going to include a plethora of your information, your data. So it's more reliable because that standard deviation is much smaller, means our data is much more clustered together. So if you're looking for a more reliable delivery time, you would go with shop 1. If you want to kind of take a chance and see if you can get an early, a really fast delivery, shop 2, there's a better chance of getting a faster delivery, but there's also kind of an equally bad chance that it'll take even longer, get up into the 40-minute range. So that smaller deviation gives more reliability. Okay, next we're going to look at airline arrival times, and actually I think we'll call it good there, and we'll finish this one off in our last video.